Have you ever wondered what makes materials strong? Or how technology can amplify their strength? These questions lay at the heart of materials science, a field where the inherent strength of substances is studied and manipulated for various applications. Take titanium, for instance, a metal known for its remarkable strength-to-weight ratio. Now imagine if we could make it even stronger. That's where technology, specifically 3D printing, steps in. This cutting-edge technique is revolutionizing the way we perceive and manipulate materials, opening up a world of possibilities. It's not just about creating objects anymore, it's about enhancing the very fabric of the materials themselves. One such example of technology enhancing material strength is the recent breakthrough by Australian researchers who have made titanium 50% stronger. Inspired by nature's strongest structures and using a special lattice pattern, this innovation has the potential to redefine the boundaries of material science. Researchers from the University of Technology in Melbourne have found a way to make titanium, one of the world's strongest materials, even stronger. Now that's a statement that packs a punch, doesn't it? But how did they manage to do it? The answer is as intricate as it is amazing. The researchers turned to nature for inspiration. They looked at the resilient structures of giant water lilies and organ corals. These plants, though light, are incredibly robust. For instance, the giant water lilies native to the Amazon River can hold the weight of a child. The secret behind their strength lies in their unique lattice pattern. This pattern, a network of interlaced strips or strands, provides an inherent strength to the structure. The researchers sought to recreate this natural design in titanium. But the task was not without its challenges. The primary issue was that the small fields within the lattice pattern bore a disproportionately large load. This imbalance could lead to structural weaknesses, defeating the purpose of the design. The researchers needed a way to reinforce these inner fields without compromising the integrity of the overall pattern. And that's where the marvel of 3D printing technology came in. Using a special 3D printer, the team set out to print the lattice pattern in titanium. Their method of choice, known as the instringing technique, involves a high-precision laser fusing different layers of metal together. This technique allowed the researchers to strengthen the inner fields of the lattice, without adding unnecessary weight or altering the structure's overall design. Through this process, the researchers were able to create a material that is up to 50% stronger than the magnesium alloy We54. This alloy, until now, held the record for the strongest material of approximately the same density and was often used in the construction of spacecraft. But with the help of advanced 3D printing technology, these researchers have overcome these challenges. The result? A titanium structure that is lighter, stronger, and more resilient than ever before. Now, that's science at its finest. The key to this breakthrough lies in the special 3D printer and a technique called instringing. This technique is a marvel of modern technology, harnessing the power of a high-precision laser to fuse different layers of titanium together. It's not simply about stacking these layers on top of each other, oh no. Think of it more like interweaving, creating a complex structure that is much more than the sum of its parts. Now, when it comes to the lattice pattern, the instringing technique has a special role to play. Remember those small fields on the inside of the pattern that would usually buckle under pressure? Well, by using instringing, we can strengthen these insides, distributing the load more evenly and resulting in a much stronger structure overall. Imagine a structure that is not just strong, but also lightweight and efficient. This technique has helped create a material that is 50% stronger than the strongest known material of the same density. This research has far-reaching implications. The potential applications are staggering. Imagine, if you will, spacecrafts that are far stronger, yet lighter than anything we've ever seen. We could reach farther into the cosmos with less fuel, making space exploration more efficient and effective. But it's not just about aerospace. The strength and lightness of this 3D printed titanium lattice could revolutionize construction, transportation, and even medical implants. We're talking about bridges that can withstand greater forces, cars that are safer and more fuel efficient, and prosthetics that are stronger and lighter. The beauty of this technology is that it's scalable. It can be used to create structures as small as a few millimeters or as large as several meters per lattice. This means we can apply it across a wide range of applications, making it incredibly versatile. This breakthrough is not just about making stronger materials, it's about pushing the boundaries of what is possible with technology and design. It's about creating a future where strength and lightness coexist, where nature and technology work together to create something extraordinary.